This is Mr. Martin. These are video notes for Pre-Calculus Honors. We are continuing with section 8.6. So a little bit more discussion on permutations and combinations. So with permutations, if our items are chosen in order without replacement from n possible terms, then the number of permutations is given by NPR. And we calculate this by doing n factorial over n minus r factorial. And then the key here is that this is in order, so the order is important. And then for combinations, if our items are chosen in any order, so the order is not important. Again, without replacement from n possible items, then the number of combinations can be calculated by n factorial over r factorial times n minus r factorial. So permutations, order is important. Combinations, order is not important. So if each item is equally likely to be chosen, the permutations and combinations are all equally likely for a given value of r. So let's take a look at a few more examples. Suppose you have 4 personalized letters and 4 addressed envelopes. If the letters are randomly placed in the envelopes, what is the probability that all 4 letters will go to the correct addresses? So let's first figure out the number of outcomes. We have 4 letters, and we need to find the permutations of all 4 of those, because the order that they go in the envelopes is going to be important. So that's 4 factorial over 4 minus 4 factorial. So that's 4 factorial over 0 factorial, and that will give us 24. So we have 24 possible outcomes. And then the probability of all the letters being correctly addressed then would simply be 1 out of 24, because there's only one correct way for the letters to go into the envelopes. Moving on to the next example, we've got in a Pick 6 lottery, 54 numbered balls are used. Out of these, 6 are randomly chosen. To win, at least 3 balls must be matched in any order. So we'll find the probability of winning the jackpot, so getting all 6 balls correctly, or the probability of matching any 5, or any 4, or any 3. So first, again, let's find the possible outcomes. And in this case, the order that the balls come out doesn't matter. It just matters that you match them. So we're looking at 54 choose 6 outcomes. So that's 54 factorial over 6 factorial times 54 minus 6 factorial, which is going to give us 25,827,165 possible outcomes. Alright, so if we're going to match all 6, there is only going to be one way out of 25,827,165 ways that we can match all 6. However, to match all 5, it's a little bit different. So match 5 numbers. So now, of the 6 that we choose, we only need to match 5. Okay, then there's 48 left, and we're going to pick one of those 48, and it's still out of our possible combinations, which was 54 choose 6. And if we calculate this, we'll get 288 out of 25,827,165. So you can see, just to match 5, your odds improve a little bit. Next, to match only 4 numbers, so now of the 6 that we pick, we're going to match 4. And then we're still going to have 48, but now of those 48, we're going to have 2 of the other 48 that aren't one of the winning numbers. Okay, so notice how up here I have 5 and 1, that gives me the 6, and here I got 4 correct, which means I got 2 of the other 48 that weren't correct in there somewhere. Again, our possible combinations are 54, choose 6, our possible outcomes. And if we calculate this, we're going to get 16,920 out of 25,827,165. And then lastly, to match 3 numbers, we would have, of the 6 winning balls, we would pick 3 of those, which means we would have to pick 3 of the remaining 48. And again, out of 54, choose 6. And that will give us 345,920 out of our 25 plus million. 165. So you can see, to match less of the numbers, your odds increase accordingly. Alright, so moving on to number 7. If you'd like to try this one on your own, feel free to pause the video. Otherwise, keep rolling and I will go through the explanation with you. So a bag contains 26 tiles, each labeled with the letter A through Z. So Julie's going to choose 5 tiles at random from the bag. What is the probability that she chooses the letters with her name in any order, so that indicates combinations, matching all 5 letters? And then what's the probability of matching 4 letters and 3 letters and actually matching 0 letters? So let's figure out the possible outcomes. So there's 26 letters and we are going to choose 5 of them. So that's 65,780. And then to match all 5, there's only one way we could do that, so that would be 1 out of 65,780. If we try and match 4 numbers, so we're going to have, she's got 5 letters in her name, and we're going to match 4 of them, which leaves us, there's would be 21 letters left, and we're going to choose one of those. And then that would be out of our 26, choose 5. So now to only match 4 increases her odds a bit to 105 out of 65,780, which would reduce to 21 out of 13,156. Now to match 3, we would have 5 choose 3 times 21 choose 2 over 26 choose 5, and that would give us 2100 over 65,780, and this would reduce to 105 over 3289. And to match none, we would have 5 choose 0 times 21 choose 5. So we're not picking any of the 5 letters of her name. We're going to pick 5 of the other letters out of 26 choose 5. And the odds of matching none are 20,349 out of 65,780. So you can see that the probability of matching none of her letters in her name is actually less than the probability of matching 3 letters in her name. Alright, so if you have any questions, make sure you ask me the next time you see me. If you happen to be watching in class, go ahead and pause and you can ask me then. And we'll see you next time.